For 95%, we got 1.96. What that actually means is if you shade in 95% of the normal curve, the z values on either end are going to be negative 1.96 and positive 1.96. The issue is, how do you get those? This is an area of 0.95. See, normally we've typed in the z value and found the area. So the issue is, how would you type in the area to find the z value? You see, that's what the issue is. And what we're going to do is, if that's 0.95 in yellow, what's the left tail area going to be? Point, want to be 2.5, want to be 0.025. Because it's highly symmetrical, it'll be 0.025 here. So basically what I want to do is find a way to go from, instead of going from negative 1.96 to 0.025, like you know how to do, I want to go from 0.025 to negative 1.96, and the procedure is, are you ready? You get out your TI 83 or 84, and you go to distributions, and instead of normal CDF, we're going to do inverse normal. Inverse normal would be working backwards. You type in area, you get the z value. All right, so you go to, do you see inverse normal down there? I'm going to type in inverse normal. And I'm just going to type in that 0.025.
Yeah, 0.025.
Are you ready? And what should we get? What do we expect the answer to be? It should be negative 1.96 because it is going to go from area down to z value. Are folks ready? It worked, negative 1.96. So you could find the corresponding z value for any confidence interval using this method. Do folks see what I did? Was that fantastic? That's inverse normal. Okay. So inverse normal goes from area down to z value. Normal CDF goes from z value to area. Can folks see that if the number of students surveyed was greater than 75, wouldn't this be a smaller number? You have a narrower interval, right? So as n gets bigger, the confidence interval gets smaller. Do we agree? What's wrong with saying the probability that Leah Berger is born on a Monday is 1/7? Do we know what's wrong with that sentence? Doesn't it sound like it's probably true?
Yeah, that does.
But why is it not true?
Might be a leap year.
Even
Well, that wouldn't really affect. That wouldn't really affect
leap
it.
year wouldn't affect. Which is 1 day out of 7 days possible.
Yeah. Here's what's wrong with that sentence. It's wrong. She either was or wasn't born on Monday. That is, you either were or weren't. You may not know. You probably don't know. But you either were or you weren't. So the chance is really 0 or 1. Either you were, in which case the chance is 1, or you weren't, and the chance is 0. So if I said, what's the chance that a random person picked at random, or the next person to walk in the room was born on a Monday, that would be 1/7. Okay? But if I say, what's the chance she was born on Monday, it's either 0 or 1, because once you pick a person, you either were or you weren't. Do that make sense?
Yeah.
So if I say, what is the probability a randomly selected person was born on a Monday? It's either 1 or, it is 1/7. But as soon as you name somebody, okay, so that's the reason why, can you see the connection? It's slightly wrong to say there's a 95% chance we're correct, that the mean is somewhere in there, because it either is or it isn't. We don't know. But it either is or isn't. I say it may be unknowable, because it's too many people to survey, but we're either right or wrong. So the chance is either 1 or 0. Do that make sense? Do that make sense?
Yes.
So the better way to say it is,
I'm gonna hear that.
we're 95%. If this experiment were done many times, 95% of the time we'd be right.
Yeah.
In other words, if this calculation were done in a similar situation many times, we'd be correct 95% of the time. But you can't technically say there's a 95% chance the true mean for the entire school is in that range. Do folks know what I'm saying?